Hi, welcome to part 3 of Breaking Bias, where we're looking at artificial intelligence and how to avoid baked-in bias. In the last part, we looked at how we train AI systems with that training data, and that awful example of where Google launched that racist app. So what's going on here? Unlike a system that we have created, an algorithm is making thousands and thousands and thousands of connections behind the scenes, and it's very difficult for us to unpick those and try and understand them. This is known as the black box problem. We know it's doing something, but we don't know how, which becomes a problem when we're moving into a world where we're starting to use machine learning more and more to make really important decisions about our lives. We need to understand what it's doing so that we can hopefully try and improve it. 99% computer vision accuracy is brilliant, but not when it's the computer vision that's driving our car. I don't want to be sat behind the wheel of something that has a 1 in 100 chance of not seeing a lamppost. Trying to understand a system to improve it was a problem that one team recently had when they were trying to create a system to detect whether a picture of a dog was of a husky or of a wolf. They trained the system on thousands of pictures of huskies to train it on what a husky looks like, and they did the same with wolves. And they had really good results, but they wanted to make it better, so they needed to understand what the computer was seeing when it was mislabeling this husky as a wolf. Now, as humans, we're probably thinking along the lines of it's got something to do with the fur patternation, maybe the size of the ears, the skull shape, or maybe the system is doing something really, really clever, like it's the micro differences between the distance between the eyes or something. No, surprisingly, it was actually the snow in the background that it was detecting. So let's just remind ourselves, computers aren't humans. They're not detecting these as objects in the real world. It doesn't know that this is a husky and this is a wolf. All it's doing is pattern recognizing clusters of shapes and colors and textures. Turns out most pictures of wolves are photographed against a snowy background, and most pictures of huskies aren't. So really all they'd created was a very expensive snow detecting machine. The AI system doesn't know what a wolf is. It doesn't know it's a 3D object in the real world, a wild animal. It's just pattern recognizing shapes and colors and textures. This highlights the importance of that training data and looking at the information that we train these systems on. Now, one of the main reasons that AI is quite appealing to us is because it matches that unbiased mental model that we have about it. We want AI to help us get to that unbiased society that we want to become. And the problem is we're often training these systems on historical data, which can tend to be quite biased. Now imagine you wanted to train an algorithm on what our world is like today, and you were going to use Google Images for that. Go on and type in CEO and see what it shows you. Predominantly pictures of men. Do the same for a doctor, men. Put in a nurse, and you get pictures of women. And if you put a face, it'll show you white faces. We may have a problem here. Or as Kathy O'Neill says, big data processes codify the past. They do not invent the future. And it's not just computer vision where Google are having bias problems. Now, in the next part, we'll have a look at other horrific cases of Google being biased and other big tech companies that are doing the same.